Your hypothalamus came in this morning with a perfectly manageable workload, temperature regulation, a bit of hunger signaling, some light hormone coordination. Nobody told it what certain people had for dinner last night. Because some people can eat an amount of food that would qualify as a geological event, push back their chair and gain precisely nothing. Not a gram. Meanwhile, the rest of us look at a breadbasket and our trousers immediately register a complaint. This seems unfair. It also seems on the surface like it cannot possibly be real. Like those people must be lying, or their scales are broken, or they have some private arrangement with physics that the rest of us were not offered. They don't, and the real explanation is stranger than any of those options. Your body is not a simple calorie ledger. It is a panicking, improvising, wildly overcomplicated system that actively fights to stay exactly where it is, and when you push it too hard in either direction, it pushes back with genuinely creative countermeasures. Your hypothalamus is the manager running this operation, and on days when someone eats an enormous meal, it is currently juggling 17 urgent tasks simultaneously while making increasingly improvised decisions. It did not budget for this. Here is what is actually happening. The first thing to understand is that your body generates heat on purpose, not as a side effect of burning fuel, as a deliberate strategy. When you eat significantly more than your system expects, your metabolism does not simply log the excess calories and file them quietly as fat. It turns up the furnace. This is called adaptive thermogenesis, and it is one of the most underestimated mechanisms in all of human biology, because it means that some bodies, when genuinely pushed, burn off a meaningful portion of the excess simply as warmth. Literally, they run hotter. Studies measuring deliberate overfeeding found that when participants consumed substantially more calories for weeks at a time, certain individuals stored almost none of the excess as fat. Their resting metabolic rate climbed, their body temperature rose. The energy disappeared as heat rather than tissue. And the people who did this most aggressively, the ones whose bodies cranked up the furnace hardest, tended, not coincidentally, to be the ones who seemed to eat freely without visible consequence. Right now, you are probably thinking, if this is a built-in mechanism, why doesn't everyone do it? That is an excellent question. Your hypothalamus would also like an answer to, because it is supposed to be managing this system, and the settings appear to vary wildly between individuals. The thermostat in some people runs hot by default. The thermostat in others runs efficiently, almost too efficiently. Every incoming calorie treated with the reverence of a precious and finite resource, stored carefully against an emergency that keeps not arriving. This is not a character flaw. It is evolutionary engineering. For most of human history, and we are talking 200,000 years of genuine food scarcity, the body that held onto every calorie was the body that survived the winter. The body that burned excess food as heat was in lean seasons, a body wasting resources it could not afford to waste. You are not broken. You are catastrophically overbuilt for a world that has a 24-hour drive-through. The famine your metabolism is quietly bracing for has not come and statistically will not. Your hypothalamus has not received that memo, but adaptive thermogenesis is only part of the story. Because there is another mechanism at work here. One so mundane it took scientists years to take it seriously. Fidgeting. Sit with that for a moment. When certain people overeat, they unconsciously begin to move more. They tap their feet, they shift in chairs, they take the long route to the kitchen. They stand when they could sit, pace when they could stand, choose the stairs with a small but consistent extra commitment. None of it is deliberate. None of it registers as exercise in the way most people think about exercise. And research from the Mayo Clinic found that this kind of spontaneous, unplanned movement, called non-exercise activity thermogenesis, which researchers mercifully shortened to NEAT, can account for up to 2,000 calories of difference between two people of similar size eating the exact same amount. 2,000 calories. From fidgeting. Your hypothalamus is behind this too, and here is the part that is genuinely strange. It is doing it without your knowledge or permission. When you overeat significantly, the hypothalamus quietly dials up your restlessness. It increases baseline movement. It makes you fractionally more likely to shift, pace, stand, fidget. It is running emergency heat dissipation protocols you never consciously activated, and it would like it noted that it is doing a remarkable job under extremely difficult circumstances. Meanwhile, there is a third system running simultaneously, and this one operates before a single calorie has a chance to reach storage. To process an incoming meal, your digestive system deploys a remarkable chemical response and involves, wait, back up. We need to talk about what digestion costs before we talk about where the calories go, because the order matters here. Digesting food is not free. It takes energy to break food down, and the amount of energy it takes depends entirely on what you are eating. Protein is the most expensive. Breaking it down costs somewhere between 20 and 30% of its own caloric value. Meaning, if you eat 100 calories of protein, your body spends up to 30 of those calories just processing it. Carbohydrates cost 5 to 10%. Fat costs almost nothing to digest. It slides through with minimal resistance, which is convenient for fat but considerably less convenient for you. So when someone sits down to an enormous protein-heavy meal, their body immediately owes the house a meaningful processing fee before anything reaches permanent storage. This is not a myth. It is a mechanism, and it stacks on top of the thermogenesis and the NEAT response, all three running simultaneously. Here is where the story takes a turn that most people do not see coming, because the obvious conclusion from everything above, thermogenesis and NEAT thermic effect, seems to point toward genetics as the only variable that matters. Some people have better settings. They were born running hotter, nothing you can do about it. That would be a neat, self-contained, mildly devastating conclusion to reach. It is also not the whole truth. The NEAT response, it turns out, is not purely fixed. Bodies that move consistently across a day build movement into their baseline. The hypothalamus recalibrates toward restlessness when restlessness is the norm. The thermic effect of food is directly manipulated by what you choose to eat. Higher protein at every meal means every meal carries a built-in processing surcharge before storage decisions are made. And the gut microbiome, the roughly 38 trillion microorganisms living in your digestive tract, which is a number you are allowed to find alarming, plays a significant role in how many calories are extracted from food in the first place. Some microbial compositions extract aggressively. Others are considerably more relaxed about it. People with certain microbial profiles absorb measurably fewer calories from identical meals. This is not willpower. This is bacteria making decisions on your behalf. The very reasonable concern here is, can any of this actually be changed? The answer is yes, and your hypothalamus, which has now been running this operation since early morning and is beginning to look for a chair, would like you to know that consistency is what it responds to best. Here is the practical part, and it connects directly to the mechanisms above. Eating more protein at every meal raises the processing cost of every meal. Not by dramatic amounts in isolation, but consistently across weeks and months, the surcharge adds up. A meal structured around protein is a meal where a meaningful percentage of the calories are already spoken for before storage decisions begin. Moving more between meals, not in structured sessions, just more, activates the NEAT system that some people have running automatically. Walk when you might stand, stand when you might sit. The gap between people who have this system running at high intensity and those who don't is partly genetic, but it is also partly a baseline the body was eased out of and can be eased back into. And eat slowly, not as a mindfulness practice, as a logistics strategy. Your gut needs approximately 20 minutes to get the satiety signal upstairs to the hypothalamus. Eating quickly means consuming well past the point where the hypothalamus would have intervened had it received the paperwork on time. By now, your hypothalamus has finally received confirmation that storage levels are appropriate and it can begin standing down from emergency protocols. It has filed its report. It has logged the adaptive thermogenesis response, the NEAT adjustment, the satiety coordination, and approximately 40 other things it managed without acknowledgement. It would like a quieter day at some point. It will not get one. That is essentially the job. The truth about people who seem to eat without consequence is not that their bodies are ignoring the calories. It is that their bodies are running multiple burn-off systems simultaneously at higher intensity than average. And several of those systems are not as fixed as they appear. Next time, what happens inside your fat cells during the 23 hours after a large meal? And why some of the decisions made in that window are considerably more permanent than others. Your adipose tissue has opinions. They are patient, quietly held, and backed by several thousand years of evolutionary commitment. You have been warned. How does your body feel the day after you eat significantly more than usual? Clearer, slower, oddly energized, or something else entirely? Leave it below, because the pattern you describe tends to say something quite specific about which of these systems is running loudest in